The full analytical capabilities of the Xraster plugin are available when it is integrated with the functionalities of QGIS. In this presentation, I will demonstrate how we can use a text file generated by the Zonal Statistics tool in Xraster within QGIS. Zonal Statistics as table in ArcGIS or Zonal Statistics in QGIS are important tools for raster analysis in GIS. Using a zone mask in the form of a polygon or raster layer, they calculate basic statistics for the values of all raster cells covered by a given zone. The result is presented as a table. Zonal statistics in Xraster work in a similar way, but since our data consists of multiple rasters in the time dimension, the statistics are calculated separately for each time point. If, at a given time point, we also have a series of rasters in the depth dimension, they are included in the calculations for that time. To summarize, the rule is one time point equals one statistics record for each zone. In the example below, calculations are performed for the surface and all rasters from the year 2022. Although the data is monthly, we enter the time slice with the same value. The output file contains the following structure. The first column, labeled Zone, includes zone numbers, followed by the date, and then the calculated statistics, mean, minimum, maximum, median, and standard deviation. Additionally, the sum of the variable is calculated. The first step is to import the text file obtained from the Zonal Statistics function in Xraster. Go to Layer, then select Add Layer, and choose the Add Delimited Text Layer tool. In QGIS, go to Layer, then select Add Layer, and choose the Add Delimited Text Layer tool. Select the file no31stat.csv. Now we can open the added file as a table using Open Attribute Table. We can see that the zone field is of type integer, the time field is of type datetime, and the statistics are of type real. The second step is optional. We can perform a selection of records in the table that we want to analyze. In the example, we will perform calculations using records from after the year 2000. We selected 304 records that meet the condition that the time field contains a year greater than 2000. Further analysis will only apply to the selected records. The third step is to use the Statistic by Categories tool, which will summarize the records belonging to each zone and calculate the statistics for them. We will open the created table. We can see that for each zone, the number of records is provided along with the calculated statistics. The final step is to join the calculated statistics to the polygon of the corresponding zone. We will use the Join Attributes by Field Value tool for this. The zone polygon layer is Baltic Subbasins 2, which contains a field with the zone number. We will join the selected statistic from the created Statistics by Category table to this layer. The key for the join will be the zone number, which is present in both tables. The created layer now contains the added column with the mean data. We can now proceed with symbolizing the layer based on the mean.